NASA's James Webb Space Telescope released its first image in July, the deepest, sharpest view we've ever seen of the universe.
Imagine a far-off, mysterious world that has long captivated the imaginations of scientists and the public alike. A world that was once considered a planet, but later stripped of its title, causing much debate and controversy. That world is Pluto. But now, thanks to the revolutionary technology of the James Webb Space Telescope, we are finally getting a closer look at this enigmatic celestial body. Scientists have already made shocking discoveries that have left them scratching their heads in amazement. What secrets does Pluto hold? How could it possibly affect us here on Earth? And most importantly, could these groundbreaking revelations be enough to reinstate Pluto's status as a planet? In this video, we will delve deep into the terrifying and awe-inspiring findings of the James Webb Space Telescope and explore the mystery of Pluto like never before. Get ready to have your mind blown as we uncover the secrets of this distant world. The James Webb Space Telescope may have been one of the most expensive and difficult to build space observatories, but it is already generating groundbreaking results and discoveries since its launch. One of its main objectives is to search for signs of extraterrestrial life by examining the atmospheres of exoplanets. Using infrared technology, the telescope will watch for a star's light to dim as a planet passes in front of it, and then ground-based telescopes can determine the planet's mass through the radial velocity technique. With its powerful spectroscopy capabilities and coronagraphs that can directly image exoplanets near bright stars, the JWST will study the exoplanet's atmosphere and other characteristics such as its color, vegetation, and rotation. Additionally, the JWST will also focus on planets and other celestial bodies closer to us, including Mars, asteroids, comets, and Kuiper Belt objects, among others. However, what excites scientists the most is the opportunity to finally study Pluto in great detail with this groundbreaking telescope. Pluto may have lost its planet status, but it remains an object of fascination for scientists, and the latest buzz is all about the James Webb Space Telescope's capabilities to capture images of distant objects. People have been asking whether the telescope can be used to study Pluto, and the answer is a resounding yes. In fact, the JWST has recently captured a breathtakingly clear image of Neptune that has caused a lot of excitement. The image was taken with a near-infrared camera and shows Neptune's bright rings and faint dust bands, which appear as fuzzy particles between the brighter ice-dominated rings. The picture also reveals methane ice clouds, which appear as bright streaks and spots and a glowing band encircling the equator. The image also includes 7 of Neptune's 14 known moons, including the largest and brightest one, Triton. With the JWST's incredible imaging capabilities, there's no doubt that it can capture stunning images of Pluto that will expand our knowledge of the planetoid. Pluto is up to something mysterious, and the James Webb Space Telescope is on the case. Scientists have noticed that Pluto's atmosphere is disappearing, and they're not quite sure why. The dwarf planet's atmosphere, which is primarily made up of nitrogen, is similar to Earth's, but unlike Earth, Pluto's atmosphere is supported by the vapor pressure of ice on its surface. So, if the ice on Pluto warms up, it can significantly change the density of its atmosphere. For the past 25 years, scientists have been observing Pluto as it moves away from the Sun. During this time, the surface temperature has been dropping, and as a result, Pluto's atmosphere is starting to refreeze back onto its surface. The temperature drop isn't expected to reverse anytime soon, as Pluto is incredibly far from the Sun, and as time goes on, it will only get further away and colder. But the JWST is on the case, and scientists are using telescopes located in the US and Mexico to study Pluto in its thin atmosphere, hoping to unravel the mystery of what's happening on this distant planet. Now picture this. You're at the beach on a sweltering day. It's high noon and the sun is beating down on the sand, heating it up quickly. As the day wears on, the sand soaks up more and more heat until it's the hottest in the late afternoon. This process is called thermal inertia, and it's what's been happening on Pluto's surface as it accumulated residual heat from when it was closer to the Sun. This has kept its atmosphere from disappearing, but as Pluto gets colder and the thermal inertia wears off, more and more of its atmosphere is starting to freeze back onto its surface and vanish. But how did scientists figure all this out? By using a method called occultation. This has nothing to do with witchcraft or the supernatural, but is just what happens when one cosmic object passes in front of another, hiding it from view. Scientists have been using this technique to study Pluto since the late 80s. By observing Pluto as it crossed in front of a star, they were able to calculate the density of its atmosphere and determine that its nitrogen ice reservoirs were kept warm by stored heat under the surface. However, with Pluto getting colder and the surface cooling down, the data suggests that this thermal reservoir is starting to wear off. Pluto is a mysterious world with many fascinating features yet to be fully explored, and one of the most remarkable is the Tombo Regio, a heart-shaped region on its surface. This iconic feature is covered in carbon monoxide ice and has a cone-shaped formation that makes it resemble a giant ice cream scoop. At the center of the heart lies the smooth Sputnik planum, named after Earth's first artificial satellite. Despite being a relatively young region, estimated to be around 100 million years old, it has already undergone some geological processes that have left it with unique characteristics. Scientists have observed dark streaks on the surface of Pluto's icy plains that appear to be aligned in the same direction. Could these streaks be the result of strong winds blowing across the planet's surface, or is there something else at play here? Have you ever accused someone of having a cold heart? Well, guess what? Pluto, the dwarf planet, has a heart despite being freezing cold. This heart-shaped region was discovered by the New Horizons spacecraft during a flyby of Pluto. It covers 1 million square miles and is made up of nitrogen glaciers, making it even bigger than a human heart. This heart also dictates Pluto's actions, as the left ventricle, known as Sputnik Planitia, forced the planet to reorient itself to face its moon Charon on the opposite side. Scientists call this phenomenon a true polar wonder, where a planetary body changes its spin axis due to large geologic processes. The current position of the ventricle, which is a cold trap accumulating nitrogen ice to make a 2.5-mile thick ice sheet, is responsible for cracking Pluto's surface and creating gigantic faults in its crust. The basin is thought to have formed to the northwest of its present location and closer to Pluto's north pole, and if ice continues to accumulate on the basin, Pluto will keep reorienting itself, so it's not free yet. Who knew a cold heart could be so fascinating? Pluto has more than a few tricks up its sleeve, and the dunes on its surface are just one of them. Unlike Earth's sandy dunes, these are made of frozen methane ice grains that have been shaped by gusts of wind. But don't be fooled, dunes aren't as rare as you might think. They can be found on Earth, Mars, Venus, Saturn's moon Titan, and even on Comet 67P. The untouched state of Pluto's dunes suggests that they were formed relatively recently, possibly within the last 500,000 years, or even more recently. Pluto presents a fascinating puzzle in this regard. Despite being billions of years old, its surface features and polygonal shapes suggest that it's a young, active geological system. The likely culprit for this activity is a process called thermal convective overturning of ice. While researchers were already surprised to discover a vast liquid ocean on Pluto, they're now grappling with another unexpected possibility: active volcanoes on the dwarf planet. Enormous faults slicing through Pluto's icy surface suggest that there's a frozen ocean below, which has gradually expanded and contracted, creating these features over time. Scientists believe that the ocean is still in the process of freezing, potentially forming new faults on Pluto's surface as we speak. If Pluto is indeed an ocean world, then the Kuiper Belt could be teeming with similar oceanic dwarf planets, which would vastly expand the list of habitable places in our solar system. Although the liquid ocean on Pluto likely exists today, it's likely isolated by a thick layer of ice, which means that it doesn't come into contact with the surface anymore. Nevertheless, it may have erupted through cryovolcanism in the past, making Pluto all the more intriguing. Let's take a closer look at Pluto's unique volcanoes. Unlike the fiery eruptions we see on Earth, Pluto's volcanoes spew cold, slushy cryolava over the planet's surface. Evidence of these icy eruptions can be found in the deep central pits of Wright Mons and Picard Mons, two enormous mountains to the south of Sputnik Planitia. West of Sputnik, long fractures and carbon show evidence of cryolavas that once flowed over the surface. In the Virgil Fosse region, scientists believed that ammonia-rich cryolavas erupted and covered an area in red organic molecules less than 1 billion years ago. But the icy eruptions aren't just limited to Pluto. Its moon Charon also has a volcanic history that could give insight into other icy planets. Thanks to the New Horizons mission, scientists have been able to study Charon's geology in more detail, but the upcoming James Webb Space Telescope will provide even more long-term observations. Hold on to your space helmets because the New Horizons spacecraft captured some incredible high-resolution images of Charon, Pluto's largest moon. And what's even more exciting is that these images have revealed 2 distinct terrain types on Charon's surface. The first is an immense southward stretching plain called Vulcan Planitia, which is bigger than the state of California. The second is a rugged terrain called Ozterra that stretches all the way to Charon's North Pole. Both of these terrains were formed from an ancient ocean beneath Charon's crust that froze and expanded. Can you imagine that? But that's not all. The mountainous terrain of Ozterra was created by cryolava spilling across the surface, forced through vents, cracks, and other openings by moderate expansion in the north or south. And wait, there's more! Astronomers have discovered similar features on icy moons all over the solar system, including Neptune's giant moon Triton, Saturn's moons Tethys and Enceladus, Uranus's moons Miranda and Ariel. By studying these detailed images of Charon, scientists are able to gain invaluable insights into the volcanic and geologic activity of other icy worlds. This is why scientists are so fascinated by Pluto and its moons. The discoveries made on this planetoid have not only illuminated our understanding of it, but also other puzzling discoveries throughout the solar system and beyond. But how did the freezing cold dwarf planet Pluto come to be? The answer may surprise you. Scientists now believe that it may have had a fiery beginning. For years, astronomers had thought that the planet's ancient subsurface sea formed gradually over millions of years due to radioactive decay. But recent findings have thrown that theory into question. A team of scientists pored over images of Pluto captured by the New Horizons spacecraft, searching for clues about how the planet was formed. They found that the presence of valleys and mountains on Pluto's surface could provide important insights into its origins. After analysing these bizarre surface features, the team created computer models that explored different ways in which the planet could have formed. They discovered that if Pluto had started out cold and then melted internally, it would have contracted, leaving visible signs of compression fractures. However, the team only found evidence of extensional features, which suggested that Pluto may have had a short, violent start that gave way to an early ocean. But how did Pluto generate the heat required for such a start? The team considered 2 possibilities. Either energy from radioactive decay warmed the proto-dwarf planet, or it was bombarded by nearby material causing it to melt. They concluded that the latter scenario was more likely. These findings suggest that Pluto's formation must have been a swift process, but in the grand scheme of things, that swift process could have lasted as long as 30,000 years, a mere blip on the timeline of the universe. Pluto, the dwarf planet that's been shrouded in mystery for so long, has once again caught the attention of scientists. One surprising discovery they've made is that Pluto shares something in common with Earth and Mars: actively flowing glaciers. Dozens of nitrogen ice glaciers flow from pitted highlands into the basin, creating valleys as they go into the east of Sputnik Planitia. These glaciers are the result of seasonal and mega-seasonal cycles of nitrogen ice that sublimate from ice to vapor, move around Pluto, and then freeze back on the surface again. But these are not like the water ice glaciers we have on Earth. Any melt within them won't fall toward the bottom. It will actually go to the top, because liquid nitrogen is less dense than solid nitrogen. And when the liquid nitrogen makes it to the top, it may erupt like jets or geysers. It's also worth noting that some of Pluto's surface is made of water ice, which is slightly less dense than nitrogen ice. When Pluto's glaciers course through the surface, some of those water ice rocks will rise up through the glacier where they float like icebergs. The largest known glacier on Pluto is Sputnik Planitia, which stretches over 620 miles or 1,000 kilometers. What's fascinating about this glacier is the network of strange-looking polygonal shapes in the ice, which is something found nowhere else in the solar system. Each of these cells is not less than 6 miles across and appears like cells viewed under a microscope. However, they're actually evidence of Pluto's internal heat attempting to escape from underneath the glacier. Warm ice rises up into the center of the cells, while cold ice sinks along their margins, causing them to form bubbles of upwelling and downwelling nitrogen ice, something like a hot lava lamp. This is a unique phenomenon that's not present in Earth's glaciers or anywhere else in the solar system. Furthermore, a recent analysis of photos taken of Pluto has revealed a bizarre area that stands out from anything else in the small world or in its cosmic vicinity. This lumpy region is home to some of the largest ice volcanoes ever observed in the solar system, and they're unlike anything seen before. Located southwest of the Sputnik Planitia ice sheet, this area consists of lumpy water ice covered in volcanic domes, with Wright Mons and Piccard Mons being the largest. Piccard Mons is 22,965 feet, or 7 kilometers high, and 139 miles, or 225 kilometers wide, while Wright Mons is roughly 13,123 to 16,404 feet, or 4 to 5 kilometers tall, and spans 93 miles, or 150 kilometers. Wright Mons is thought to be comparable in size to the massive Mauna Loa volcano in Hawaii. These ice volcanoes formed by moving material from the subsurface to the surface, creating a new landscape. When the water on Pluto's surface froze, it formed snow-covered mountains that may resemble those on Earth, but they're entirely unique. It's challenging to compare the appearance of these features to any other volcanoes in the solar system, icy or rocky, as they don't have calderas at the top and are covered in significant bumps. Concerning these glaciers on Pluto, scientists have made yet another fascinating discovery about these icy formations. They actually grow with the seasons. Although Pluto is always cold, temperatures can vary between a frosty -418 to -364 degrees Fahrenheit. This means that the dwarf planet experiences warmer seasons. During these seasons, methane and nitrogen molecules move more freely within the solid ice because they are not strongly bound together. Researchers used a high-intensity neutron diffractometer called WOMBAT to recreate the conditions on Pluto and observed how the molecules behave. They found that as the temperature warms up, the molecules change their orientation, leading to changing densities in response to temperature. Surprisingly, nitrogen molecules can cool into an ordered structure known as the alpha nitrogen phase, causing a big volume drop. At slightly higher temperatures, around -380.47 degrees Fahrenheit, the nitrogen molecules become plastic and freely rotate. Who knew that molecules could be so fascinating? Is it possible for life to exist on Pluto in any form? Unfortunately, the extreme surface conditions on Pluto make it impossible for life to exist in any form. With temperatures so cold that not only water but also other gases and liquids such as methane, nitrogen gas, and carbon monoxide freeze solid, there is simply no chance for life to survive under these conditions. The atmospheric pressure on Pluto is also much lower than that of Earth, further reducing the possibility of life on its surface. However, scientists believe that there may be a chance for life to exist inside Pluto. And what is the interior structure of Pluto like? Scientists have determined that Pluto has a core made up of dense rocky material surrounded by an ice mantle. The core's diameter is approximately 1,700 kilometers, and the ice mantle is estimated to be between 100 and 180 kilometers thick at the core mantle boundary. Despite the frigid temperatures on the surface, there could be a liquid ocean of water within Pluto, resulting from the decay of radioactive elements that would heat the ice and cause the rock to separate. Scientists predict that in the future, the conditions on Pluto may change to allow for the existence of life. However, this could spell disaster for Earth. Although Pluto is currently outside of the Sun's habitable zone, the Sun will eventually expand and emit more energy for several million years, making the outer solar system part of the habitable zone. This expansion will occur over the course of 500 million years, and as the Sun grows, it will consume the inner planets, including Earth. During this time, the Kuiper Belt objects, including Pluto, will warm up significantly. However, given their composition and the limited time window, it's unlikely that life will evolve on Pluto without intervention. Humans may need to transport vegetation and organisms from Earth to seed Pluto and other surviving bodies. Don't worry though, these cosmic events are still billions of years away. Furthermore, Pluto is quite a remarkable celestial body, and one of the fascinating things about it is that it shares an unusual characteristic with its moon, Charon. They both have almost no small craters. While this might seem like just another peculiar attribute of these two celestial bodies, the scarcity of small craters has significant implications. Small craters are a common feature on the surface of most planets and moons, but Pluto and Charon are unique in their complete absence of them. It seems that on this distant dwarf planet, located on the fringes of the solar system, it's all about go big or go home. Scientists were surprised to find fewer small craters on Pluto and its moon Charon than they had anticipated. This indicates that there are fewer small Kuiper Belt objects than previously thought. This conclusion was drawn after examining the images of craters taken by New Horizons, which showed very few objects with a diameter of less than 1 mile had struck either world. Since there is no reason to assume that tectonic activity would have wiped out small craters, the only logical explanation is that there are not many very small objects in the Kuiper Belt. This discovery is not just relevant to Pluto, but also provides astronomers with insights into how the solar system formed. It helps identify the population of building blocks of larger objects, such as Earth. For a long time, scientists believed that Pluto's rocky core lacked the internal energy needed to create volcanoes. They thought that several eruptions would have been required to form the area. In addition, the lack of impact craters in the region, which can be observed across Pluto's surface, suggests that the ice volcanoes were active relatively recently, indicating that Pluto's interior has more residual heat than expected. This implies that our understanding of planetary systems is incomplete in terms of geological timescales. The study of Pluto using the James Webb Space Telescope promises to reveal more about this distant dwarf planet and its unique features. The absence of small craters on Pluto and its moon Charon has raised intriguing questions about the Kuiper Belt and the formation of the solar system. With the help of the JWST, scientists hope to learn more about the geological history of Pluto, including the presence of ice volcanoes and a potential subsurface ocean. The insight gained from this research could expand our understanding of planetary systems beyond our own and deepen our knowledge of the universe.